Here's a couple questions involving radicals. Here they're both cube roots, and if I'm multiplying these, which there's no operation in between, so it means I'm multiplying, I can put it all under 1. So I'd have 6 times 9, that's 54. And then n plus 4 squared times n plus 4 to the 8th would be n plus 4 multiplying common bases, add their exponents would be 10. Oh, and it's a cube root. So cube root, meaning I have to have 3 things inside to bring 1 out. Let's do this one first. I've got 10 things, so I've got 3 sets of 3 that I could take out, and I'd be left with 1 inside. So if you picture 10 of these things all in a row, for every 3 of them, because of that index, because of every 3, I can take 1 out. So altogether, I can take out 3 of these, and I'll be stuck with 1 of them inside. Okay? Hopefully you're okay there. And now 54, I'm looking again for 3 things that are the same. If you do a 54 factor tree, if you want, it's 9 times 6, and 9 is 3 times 3, and 6 is 3 times 2. There's 3 things right there that are the same that I could bring out. And so I could bring, there's 3 3s, so I bring 1 3 out, and I'd be stuck with a 2 inside. So there's my answer if they ask me to simplify that thing. Let's try another one. They all sort of get to be the same. So square root, so I can put them all under 1 square root, so I have a 2, and then x and an x, that'd be an x squared. Y and y to the 4th would be y 5th. Oh, and I forgot the 14. 14 is 2 times 7. Since the index isn't written, we assume it to be a 2. So 2 things the same inside, bring 1 out. Here's 2 x's, I'll bring 1 out. These are gone. Now I have 5 y's, so I could bring 2 sets of 2 y's out, so I could bring a y squared out, but I'm going to be stuck with 1 y inside there. Okay, oh, here I have 2 2's, I can bring a 2 out. These guys are done then. Oh, this one I've taken care of already too. 7 I can't do anything with, so I have to just leave it there. So there would be my answer to simplify that expression. Here's one as a quotient, and you can do a similar kind of thing. This time I'm looking for 6 things inside that are the same to bring 1 out. Well, 6 goes into 48 8 times, so there's 8 groups of 6 m's there. So I could bring m to the 8th out, and there's 6 groups of 6 in there, so I could bring 6 n's out. Now 64. 64 is 8 times 8, and then 8 is 2 times 2 times 2, and so is that one. So 64 is actually 2 to the 6th. So again, there's 6 groups of 2 in there. I can bring 1 out. So there would be my answer to that question. Lastly, dividing, same kind of game. I guess we can divide them as they sit, so I'd go square root. 56 divided by 2 is 28. X to the 5th, there's no x's down to the bottom, so I'm stuck with all those x's. Y to the 6th divided by the 4th, common basis, subtract their exponents would be y squared. 28, maybe let's rewrite that. So it's 2 times 2 times 7, I think. 2 times 2 is 4, 4 times 7, that's right. X to the 5th, y squared. Looking for 2 things in that I can bring 1 out. Here's 2 2's, I can bring a 2 out. 7's, no, I'm going to be stuck with the 7 in there. There's 5 x's, so there's 2 groups of 2 that I could bring out, so I could bring an x squared out, and I'd be left with 1 x inside. Y squared, there's 2 y's, so I can bring 1 out. So those are gone, I bring 1 y out. Done. Okay, hopefully that helps you. Doing this 28, another way you could have written that is square root of 4 times square root 7, because that's 28. And then the square root of 4 is 2. That's where I get this 2. And the root 7, it's stuck underneath there. Okay, hopefully that helps you with those radical questions.